Okay? If I have the logarithm of 5x squared, I need to be very careful, okay? Because what is being multiplied here? 5x. Well, 5 times, not just x, but x squared, right? So could I rewrite this as the logarithm of 5 times x times x? And now the addition rule says that this becomes the logarithm of 5 plus the logarithm of x plus the logarithm of x.
Could you do plus the logarithm of x squared or no?
Yes, you could. However, I want to make this as simple as possible. And right here, Seth, I have two of the same thing. So this becomes the logarithm of 5 plus 2 times the logarithm of x. Does that make sense?
Yep.
Okay. A very common mistake that I want to teach you how to avoid. There is no rule that says that if you have a sum, so here's an argument of x plus 5, that's a sum. There is no rule that says that this is equal to the logarithm of x plus the logarithm of 5. This is totally false. Totally false. And one of my goals, Joshua, is to teach you to avoid that like the plague. Okay, so if you have a sum or a difference on the inside, you can't do much. Okay, it's only when you have a product on the inside that you can use this rule. Okay, are we okay with it? Go ahead.
There was like another number outside of the parentheses, like a 3 or whatever.
Yes, let me show that then. Let's say I had the logarithm of x times x plus 3. There is a product here. It's x times this. So this legitimately breaks up into the logarithm of x plus, yes, that's exactly right. That's legitimate. Okay? But again, because right here, Doris, there's an addition sign, can't take it any further. Addition or subtraction. Addition or subtraction. Can't take that any further. Okay? All right. Let's talk about the subtraction rule for logarithms. We got the addition, so let's do the subtraction rule. The subtraction rule simply says that if I have the logarithm of 5/2 of a fraction, then what happens is this becomes the logarithm of the numerator minus the logarithm of the denominator. Let me show you why that makes sense. Can I take the logarithm of 5/2 and write it as 5 times 2 to the negative 1?
No.
Why not?
Because it would be 5 times 1/2.
That's exactly right. It would be 5 times 1/2. But isn't that 5/2?
Yeah.
So yes, I could do that, right? Now, if I use my addition rule right here, this would become what? Log of 5, log of 2 to the negative 1. Right? Now, there's a rule that I'm going to tell you next, Abby. It's called the power rule, but I'll use the power rule now. The power rule actually says you can bring down a power here to the front. And so this becomes the logarithm of 5 minus the logarithm of 2. So I kind of used a rule I didn't teach you yet. I kind of cheated a little bit.
Wait,
Yes.
if it was like a negative 2?
Then you could bring down a negative 2.
Alright, so it would be negative 2 log 2.
That's exactly right.
Which would be
Nope, because if it's just LOG, LOG is base what?
10.
10, so it doesn't disappear. So the base has to match the argument in order to make it disappear. Okay? Now, what if I have the logarithm of x times x plus 1 over x plus 2? Well, first, let's look at the numerator. What is the numerator? It's x times x plus 1.
So that's log x plus 1.
So log x times x plus 1. You're right. You told me what the next step would be. I'm just going to take it one step at a time, though. So log of x times x plus 1 minus what? Log x plus 2. But then Abby already saw that this was a product. So this will expand as log of x. What? Minus log x plus 2. And that's as far as we can take it. Can't take that one any further. Okay? So far we've done 2.3 rules. We've done an addition, a subtraction, and I cheated. I showed you a power rule. I'll do that now. I'll do the power rule now. Okay? So now we'll do the power rule for logarithms. Okay, if I have the logarithm of 2 to the third power, this is exactly the same as 3 times the logarithm of 2. Which means, I had a professor in college, a Korean man, and he would hit the board every time he did this. He said, power down! He'd call this the power down rule, right? And so he'd say, okay, what do we do now? We use power down, yes? Okay, so you'll see me doing that from time to time just out of affection for him. So if I have the logarithm of xy squared, Caitlin, I have to be careful, okay? I cannot power down the 2 because this is x to the first times y to the 2. So I actually have to use the addition rule first. So the rules that you use can't just be used whenever. You have to use certain rules first. So what would the addition rule say?
Log x plus
Log y2. I'm going to take this painfully slow right now. And now I can use power down, right? So this becomes log x. Oh, he was just a hurricane. He'd walk in. Okay, da 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 da. You got it. Cool. Let's go. Da 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 da. And smoke would be coming off the paper because you'd be writing notes so fast. And it was just like, oh. And he'd say, I haven't slept for 48 hours. I need energy. I'm going to go for a run. I'm just like, what are you talking about? So if you ever go to Liberty and see Mr. Moon, tell him Mr. P or John Partridge says hello. He might be. I don't know. It's been a while since I've been there. But the power, it's been a while since I've been there. But right here, Caitlin, you can power down the 2. So you have now log x plus 2 log y. And there it is, okay? This is another place, Joshua, you've got to be careful, okay? You must be very careful. I've seen this a lot of times. I've seen students say, okay, this is 2 logarithm of xy, but that's not true. Because if you put the 2 back up, what happens? X squared y squared, and that's not what you had before.
So why aren't you writing it log x plus log y plus log y?
I can.
This is a shortcut?
This is the shortcut. The power rule is the shortcut rule. It allows us to, because if I had log y to the 17, I am not writing log y plus log y plus log y plus log y plus blah, 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 plus log y. So I'm going to write 17 times log y. Okay? It is very convenient. All right, now, what if I have logarithm of 3x squared square root of x plus 2? All right. First of all, let's look at the products.
3.
So this becomes logarithm of 3 plus logarithm, let's take this painfully slow, logarithm of x squared plus logarithm of square root of x plus 2. Now this power rule says 2 can come down. So this is logarithm of 3 plus 2 log x. And it may have been a while, but remember the square root is the same as the 1/2 power. So the square root of x plus 2 is the same, bless you again just in case, is the same as x plus 2 to the 1/2 power, and that's a power, so the power rule still applies. So this would be plus 1/2 logarithm x plus 2. That's exactly right. Does that make sense? Okay. Take a shot at this. Take logarithm of x cubed square root y all over z to the 5th, and see if you can use the 3 rules that I've taught you so far to simplify that as completely as you can. As completely as you can. If you do that, you should get 3 log x plus 1/2 log y minus 5 log z. Does that make sense?
What about like going from like that back to that?
Yes. This right here is called logarithmic expansion, what we just did. And so what you're talking about is logarithmic compression. So if I have 3 log of x, let's say plus 2 logarithm of x plus 1 minus 5 logarithm of x squared plus 1. Now let's take this and compress. So this right here would become logarithm of x cubed plus logarithm of x plus 1 squared minus logarithm of x squared plus 1 to the 5th. Does that make sense before I go any further? How are we doing, Seth?
Yeah.
Make sense? I'm just using the power rule backwards now.
Yeah.
Now this is a plus right here,
That would go on top of the numerator.
and then this is a minus, so this goes in the denominator. So this finally becomes logarithm of x cubed x plus 1 squared all over x squared plus 1 to the 5th power. And that right there, Sydney, is logarithmic compression. Make sense? All right. Take your calculators out. That is not my calculator. Okay, let's talk about the change of base formula. If I wanted to compute the logarithm of 8 on my calculator, let me close this task again and open it up again. Let's try that. Computing the logarithm of 8 is pretty easy, right? All you have to do on your calculator is what? Yeah, log 8, close parenthesis, enter. And there's the, oh!
You put
What did I do? Oh, I put 2 of them in. Logarithm of 8. There we go. There we go. So that's easy, right? Now, can you compute the logarithm base 5 of 8?
not easily, not we don't know how to do it.
Right.
There's a way to do it.
And that's why you need the change of base formula. Okay? So the change of base formula says that if you have a base, Seth, that's not the same as your calculator base, you only have 2 bases on the calculator, Joshua. They're 10 and e, right? Then what you do is you take the logarithm of the argument divided by the logarithm of the old base. So it's always going to be logarithm of argument divided by logarithm of old base.
Old base meaning 5.
Right, the old base was 5. Now the base is what? 10. So now what I do is I type in log 8, close parenthesis, divided by log 5, close parenthesis, and there's the log base 5 of 8. Now, let's interpret that. What does log base 5 of 8 even mean? What does it mean? 5 to the what power? And we're actually looking at the power right now, 1.292029674. So 5 to that power, Seth, should be 8, right? So if I take 5 and raise it to this number, I'm going to use my answer variable, because that's the last thing I calculated. And I hit enter, I get 8. There it is. Okay? By the way, could I have done this? Logarithm base 5 of 8 is equal to ln 8 over ln 5. Let's try it. ln 8 divided by ln 5. So the change of base formula doesn't care whether it's common or natural. And that even makes us more powerful as mathematicians, because now we can expand things. Yes, fuel the energy, the mathematics flow, right? Okay? Really quick, here's a quick quiz. The natural logarithm of 8/5 is equal to the natural logarithm of 8 divided by 5.
False.
False. Blatantly false. That's right. The natural logarithm of 8 minus the natural logarithm of 5 is equal to the natural logarithm of 8 divided by the natural logarithm of 5.
True.
False. Blatantly false. Our subtraction rule does not say that the subtraction becomes 2 logs. So this is not true. This becomes what? ln 8/5. Okay? So it doesn't become 2 logs. That right there, Joshua, is another mistake I see quite a bit.
So division can go to subtraction, but subtraction can't go to division.
Say that again. Division can go to subtraction,
But subtraction can't go to
but subtraction can't go to the division of 2 logs.
Okay. So like for the addition one, you couldn't go backwards, but for this one you can?
For addition, logarithm of 5 plus logarithm of 3, there's really no temptation here. What would this become? Log of 5 times 3, so natural log of 15, right? But here's the mistake that students make, and this is what I want to teach you to avoid. When it comes to the subtraction of 2 different things, there's something in the human brain, for whatever reason, when you're first doing this, the temptation is to keep both logarithms and say this is the log of 5 divided by the natural log of 3. But that's not what the subtraction property says. The subtraction property says that this becomes 1 logarithm. Only 1 logarithm, and the argument is what becomes the quotient.
So you can take the subtraction property backwards, like go from division to subtraction.
Absolutely. You could still revert the 2, but you got to be careful how you're reverting them. Addition, I've never really seen students make very many mistakes on that. It's the subtraction one.
So there is a difference between the log of 5 over the log of 3 and the log of 5 over 3.
Huge difference. Let me show you. So let me take the natural log of 5 divided by 3. So 5/3 is the argument, right? I hit enter. I get 0.51082, blah, 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 blah. Now I take the natural log of 5, and then I divide by the natural log of 3, and I get a completely different real number. So they're not the same. They're not the same. They're totally different. That's going to come with practice, but that's something you're constantly going to be drilled on, too. The properties that we're learning, Caitlin, they're very good, they're very useful, but they're also easily to abuse. The subtraction one is easy to abuse. The power rule is easy to abuse, too. Okay? All right. So when it comes right down to it, what we want to be able to do is we want to be able to solve logarithmic equations. And I'm going to write this as 5 log x. There we go. 2 log x plus 1 equals 5 log x. Okay? So, now we're going to start using our properties. So the first thing, what do we do first?
Bring the 2 up, X.
Okay, so Abby's going to bring the 2 up. So she's going to say logarithm, she's going to say logarithm of x squared plus 1 equals logarithm of x to the 5th.
Would you subtract the log x to the 5th over, since it will become a division, instead of, right?
Now let me show you, we've done nothing wrong. I could have also taken this 2 log x here, subtracted it to the other side. Since the arguments are the same, x and x, it's 3 log x.
Wait, how do you get 3?
5 minus 2. 5 log x minus 2 log x is 3 log x.
Oh.
But what we've done is not wrong, and I'm going to show you that we'll get the exact same thing. So what I'm going to do now is I'm going to subtract logarithm of x squared from both sides. This now cancels away, so I'm left with 1 equals logarithm of x to the 5th minus logarithm of x to the 3rd. But we have a division rule now. It becomes the logarithm
Minus log x to the second.
x to the 5th over x to the 3rd is what it becomes, but that simplifies. So this is what it becomes, but then that reduces to x to the 2nd. So this equals logarithm of x squared.
Don't you take, wouldn't it be log x to the second on the bottom of that, because you subtracted x to the second on the other side, because that's what it was.
Yeah, you.
Oh, I'm sorry. That's a 2, isn't it? That's a 2.
Why is it
Well, I get what you're saying. But
So this is a 3.
I just put an answer. Do an actual subtraction.
Yeah.
I subtracted log x squared over here. Now I'm using my subtraction rule. So this becomes the log of x to the 5th over log x squared.
Oh, okay.
But what is x to the 5th over x squared? It's x cubed.
What happened to the 1?
What happened to the 1? It's over here on the equation.
So is that your answer? 1 equals log x to the 3rd?
I don't have an answer until I have x equals some real number.
Okay.
Yes, sir. Oh, okay. Now, I don't mind taking this slow. Does anybody else have another question on
Wait,
this?
would you leave it like that? Because you wanted it solved.
Then I wouldn't leave it like that
So how
because
do
I
you-
want it solved.
How would you solve it?
Well, that's what we're going to do next. I just want to make sure you're comfortable with what I've done. Okay. All right, I'm going to erase this, and now I'm going to write 1 equals logarithm of x cubed. And this is where we convert from logarithmic form to the exponential. So what is the base of the common log? 10. So converting this would mean what?
And
10
to the
to the
first
first,
equals x to the 3rd.
x to the 3rd.
Then you just need to cube root.
Yeah. So x equals the cubed root of 10.
So you set your base equal to your argument.
You set the base to the power on the other side, because remember, the logarithm is nothing more than a power, right?
Yeah.
So the logarithm of x cubed is a power of 1. That's what that equation says on the left.
Okay.
The logarithm of x cubed is a power of 1. So what you do is you take your base, raise it to that power, and set it equal to the argument. And then after you have this, you check back in the original. So I take my calculator, I take 10, and I raise it to the 1/3 power. Just like that, 10 raised to the 1 divided by 3. There's my approximate answer. And I plug this back into the original, which was 1 plus 2 logarithm of x. I want to see what that gives me. That's equal to 3. I want to see if that's equal to 5 logarithm of x. So 5 logarithm of got to be careful here, Seth. I can't use ANS again because I just hit enter and now ANS is equal to 3. So I've got to go back to this number.
Yay!
What was the original equation? 1 plus log x, 2 log x equals 5 log x. So 5 log x. 10 to the 1/3, 2. I know I did something wrong and I want to know what I did wrong. 1 plus 2 log x equals 5 log x. That's the original, right?
Yep.
Okay, so we solved this. So we did 10 to the first equals x cubed. So 10 raised to the 1 divided by 3 is that. I'm going to store that into my variable. Because it's the cube root. And that would be the 1/3 power.
Wait,
So
did you just
cube.
put your answer into x?
Yes,
now
I
your answer
is the x value.
new things.
Yep. And
What did you press?
I pressed stow
Okay.
for store.
And then, how do you get out of it after you don't?
All right, so now what I do is I check what is 1 plus, not 11, come on now, 1 plus 2 logarithm of x. Now that I've stored that value in, I can, there we go. I must have done something wrong before. There it is. And now what I do is I test 5 logarithm of x. Oh, come on. X, thank you. Enter. There we go.
Okay.
How do you do the?
So how do you like get out of the storing the x and the x? Like how do you delete that?
How do I
Delete it because you won't want it.
Yeah, how do you delete the stored variable?
That's a good question. I usually just end up, if I want x to be something new, I then store something new in x. I know there's a way you can go back in and just delete what's in x.
Well,
I know you can.
But how do you store?
How do you store?
Yeah, how do you
Well, let's say I wanted to store the number 9 into x. I type the number first, the number you want to store, and then hit store. And I don't even have to do x. I could hit the alpha key and type f, and then that stores the value of 9 into the variable
What
f.
if like you want to store something that you had as an answer before?
Okay, so let's say I do an answer 5 times 9 and I get 45, right? That's now stored in ANS. So all I have to do is hit the stow key and it immediately assumes I'm going to take the value inside of ANS and store that into x.
What if you want to say something before, like in the equation before?
Well, you'd have to scroll up
And then you just click enter?
Now,
and
will
then you
this-
hit store. So if I wanted to store like I did last time, if I wanted this number here in x, I'd scroll up to that number, hit store, and then it will grab that number. For whatever reason, it's performing doggedly slow right now. Your calculator won't do this, but my application's now running exceedingly slow. But I'd hit store, and then I would store that into x.
Okay. So how would that change your like if you went into y and you did like 5x plus 1 and the graph it, will it change the graph?
Well, I don't believe so.
Oh.
I don't believe so.
And if so, then you don't use it. Okay.
Okay? Okay.
Great.
All right. Let's say I have 3 plus logarithm of x minus logarithm of x plus 1 equals 4.
Oh, I took
Okay? Well,
Division problem?
if I was to give you a strategy to help you solve these logarithmic equations, then what I would say here, Kate, is I would say make sure your logarithms are on one side of the equation. And yes, I spelled the wrong. Okay. So all I'm going to do here, Seth, is I'm going to subtract 3.
And then you can use your division.
And then I can use my division property. So this becomes what? Logarithm
X equals 1.
Yep.
Alright.
Now it's time to do what? To convert
10.
from what? From logarithmic form into exponential
Yes, like
form. So, okay, what's the base?
10.
10. So what would the conversion say?
X over x plus 1 equals 10 to 1.
Yes. Now I multiply x plus 1 up. So this is x equals 10x plus 1. Distribute. X equals 10x plus 10. I would end up subtracting 10x to the other side. And that would give me negative 9x. And then I would divide by negative 9. So it would equal 10 over negative 9. Or negative 10 over 9. Now, in order for this to be a solution, I'd have to plug this back in to the original equation and see if it works.
Now I'm going to try the x thing.
Well, just a second. I don't want you to miss this part right here.
Okay.
Let's take 10 over negative 9, plug it back in here. Is there a problem if I replace x with 10 over negative 9? There is a problem. What is the problem? The argument cannot be negative. So that means that even though I did all the mathematics right,
No valid.
no solution
I don't get to use the x.
to that equation.
You were so happy.
Okay?
Haha, you were so happy.
Right here, Joshua, this is why you have to plug everything back in. When you solve a logarithmic equation, Kate, you must plug your solutions back in to see if they work.
It's a letdown, all that work.
It can be a letdown. It can be a letdown, certainly. Okay? All right. I'd like to do one more. Let's see if I can construct it. Let's take logarithm 3, logarithm x squared, plus 5 equals log x.
Wait, why would you have a 3 log x squared? Why wouldn't you bring this 2 to the top?
Because I want to. Now there's a couple of things that I can do. What's one thing that I can do?
Should the log on one side.
I could get the logs on one side. So I can subtract this logarithm over here, and I'll subtract the 5 to the other side. So this becomes 3, I don't know why I put the negative there, 3 logarithm of x squared minus logarithm of x equals negative 5.
Alright, good question.
Yep.
Would you want, okay, so I did it the other way. I subtracted the 3 log x squared over to the other side.
And that's perfectly legitimate.
Alright, but would you want, since it's a negative 3, to multiply negative 3 times the 2?
Okay,
Yeah.
we can do that.
Would you want to do that?
Would I want to do that?
Yeah, or would it just make it more complicated?
No, I think that would make it easier.
Oh, base.
Okay,
Your base.
so here's what we're going to do. We're going to bring down this 2. So this becomes what?
Log x to the 6.
6.
Oh, couldn't you do a log x to the 6?
Yes. But I think that would I mean, it's not wrong to say log x to the 6th, but this will become easier because, yeah, there you go. It's now 5 log x. And what I hope you see from this lesson so far is that there's no one way to solve a logarithmic equation, so long as you're doing the steps correctly. So that means that logarithm of x is equal to what? Negative 1.
Why?
Okay, nope.
You divided by 5?
I divided by 5.
Nice.
You can do that?
Sure.
Oops. This is totally not.
But how do you get that x on one side?
Good question.
Convert.
We convert from logarithmic to exponential.
Oh, you take the 10 to the first. or
10 to the negative first
Was that
equals x. And what is 10 to the negative first? 1/10. Are we done?
No, check.
Check. And it turns out that when we take 1/10 and plug it back into here, it's not a problem. So it will work.
So, Mr. Partridge,
Yes.
I did it the other way, not subtracted the 3 log x, and I got really big numbers.
Well, then something was done wrong. You subtracted this to the other side, right?
Yep.
And then you needed to say after that log x minus log x to the 6th.
To the 6th.
Because the 3 has to go up. You can't.
Oh, yeah, but I had. Great.
This isn't actually that hard.
Stuff. It's great. Yeah, but. Oh.
Okay.
I got
Now-
it. That was to the negative 6, not minus 6.
You're going to be doing not Fridays on the board because we're a lesson behind. You're going to be doing what's written down for Thursday. So you're going to be doing Thursday's assignment.
Is it Friday?
Today is Friday.